Hi, I'm David Latchman, and this is the Science Bloggers Podcast. This is the show where we talk to science bloggers, YouTubers, and podcasters about everything related to science and science communication. This is also our very first episode, so thank you for joining us. In today's show, we talk about mathematics with graduate student and science blogger Paula Rowińska. Paula studies the impact of wind on energy prices. And in her blog, Certain About Uncertainty, she looks at the mathematics in our everyday lives. So, hi, Paula, how are you?
Hi, how are you? I'm very good, thanks.
I'm fine as well. So, you are a PhD student in mathematics, right?
That's correct.
And you're looking at the impact of wind energy on electricity.
Yes, at the moment, yes.
So what exactly does that mean? You know, why is this a problem to be solved?
So, because we are aware of climate change and we know we need to somehow shift the energy production to renewables. The problem with renewables is that they are quite hard to predict how much energy we'll get. So if we miss it, if we miss the production, right, we either have blackouts or we have really high costs. There are things going wrong. That's why it's just so important to see how much wind energy or other renewables will produce and how it will influence the prices, because obviously energy providers care about the prices and we as consumers care about the prices.
Oh, so this is something like a demand pricing model where...
So not really. So what I'm doing is actually looking at prices themselves. So I take a time series of prices, historical prices, and I model them. So I try to explain the prices, but I include in the model the wind energy production. So for me, wind energy production is kind of one of the variables that explain the prices. Not fully, but it's one of the factors.
Okay. So that means you're looking at, at historical data on how winds blow. Is that correct? And you're probably looking at energy production.
Yes, that's correct.
Okay, that's cool. So sometime last year you did a TEDx talk on having a maths party, right?
Yes.
And you're looking at everyday applications of mathematics.
Yes.
Right? So one of the things that you looked at was the birthday problem, right? And you mentioned that some of the mathematics that goes into solving that problem also relate to precipitation predictions. How exactly does that work?
Well, so it's a very vague relation, I would say. So what I was trying to convey is that probability and statistics basically underlie most sciences. I can't imagine really doing science without any probability and statistics. So I gave birthday paradox as a very simple example of how we use probability, how we can count probabilities, count chance of something happening. And with precipitation, we watch the news, we watch the weather forecast, and we see what's the probability of precipitation on such and such day. And obviously, it's a similar idea behind this. So we are not sure. We just say how sure we are that it will rain or not.
I see. So with climate change, how is it affecting your predictions so far?
So I haven't really looked into climate change so far, because I'm looking at quite short time periods in my PhD. However, at the moment, actually, I'm in Exeter doing an internship in Met Office, so a big weather forecasting, climate forecasting company here in the UK. And I'm looking at how humidity is changing with climate change. So I just started the project, I must say, but we know that the humidity is increasing over land, which is something important to look into.
Okay, I see. So you seem to be very interested in how mathematics apply in person's everyday life, right?
Yes.
That is one of the subjects that you focus on for your blog, Certainty About Uncertainty. So how did you come up with the idea and the blog name?
I think I was changing the name for a while when I started the blog, but because I write about different sciences, different areas of mathematics as well, but I think many of my posts are about probability and about statistics and about uncertainty, because that's what my PhD is about, that's what my main interest in mathematics are about. So how to quantify uncertainty in different areas of science and of life. And, I'd like to say that I'm certain about uncertainty in the fields I work on. And probably it's a goal for me, not current state, but that's how the name, how I created the name.
Okay. So who do you think will be interested in a blog like this? Who are you trying to talk to?
So I'm actually trying to write for people who don't like maths, or maybe like it but think it's useless. So I must say that at school I didn't particularly like mathematics, because it's numbers, it's computing the same thing all over again. Only later I realized, that we can apply it to so many really interesting things and really everyday life things. So that's, I think, the goal of my blog, to show that maths is, it's numbers, but not really, not only. And we compute integrals just to understand some really interesting phenomena. So I think the blog is for people who are not mathematicians and not even scientists, but who are willing to just, who are interested in learning something new.
Okay, so why do you think some people do not like mathematics? Why does it scare people so much?
I think the problem is with education. At least that's my experience, because I feel that we learn only the skills in mathematics. So we do many examples of calculating something. And that's important. Don't get me wrong, it's very important. We have to do it. But I feel it's a bit like learning languages just by learning grammar, We don't see how important it is. And the question that many people ask is, will I ever use it, right? That's useless, that's pointless. And that's the problem. And that's why I also write about it in blog, to show people how we use some mathematical concepts. So I think that's the main issue.
Well, I think you're right in some ways, is that we have, a preconceived notion of what mathematics is when you do it in high school. When I was an undergraduate, right, I think like the first day in a maths lecture, one of the professor actually said, "Oh, you guys have never done mathematics in your life. You've just been doing sums, right?" And I think it was a set theory lecture. And, that's when I first realized it's not just about calculating numbers. It's so much more. And, I don't think people really get that chance to see that, because in high school you just focus on numeration. So.
Yes, exactly. So when I went to university to study for a mathematics degree, I felt like I had no idea what was going on. Like, it didn't even resemble the mathematics I had at school. Because also the fact is that in most sciences we learn about new discoveries. When we are doing chemistry, physics, we learn about new things that are discovered. But mathematical education basically ends with like 19th century, maybe in high school. So it feels like everything has been done in mathematics. There's nothing to be done. It's boring. And I feel we don't talk about the really interesting open problems, the applied problems in maths.
So how do you think schools can get in on this to show students that, okay, well, we have advanced considerably from the from the 19th century to today?
I think, so we obviously must remember that it's hard to understand many concepts until you have to do these boring, easy steps before you get to these more exciting ones. But I think sometimes showing what we are aiming for is really helpful. So, for example, in my TEDx Talk, I talked about concepts that are extremely difficult to understand, that I personally, I learned about them in university, but I can't say I understand them fully. But I think showing just the basic idea without details, it's very motivating for me. You don't have to fully understand, but when you have something to look forward to, you are more willing to learn.
Yeah.
So I think at schools it would be nice to just have, some basic idea of what mathematics really is and where we can use things.
Right. Yeah, I think that's a good example. If you look at the birthday paradox that you talked about in your TEDx talk, right? If you ask someone to solve their problem, even if they have a basic idea of probability theory and how to calculate certain things, calculating a problem like that, it's not something you can totally figure out on your own, right? You still have to learn skills of how to dissect that problem, right? So if you have like one person, his birthday is going to fall on, the chance of his birthday is going to fall on a certain day, the next person, and at what point is a chance of having X number of people in the room who share a birthday, right? So I think that's something that, people don't always grasp on their own because they can't always do that.
Yeah, and that's totally okay, but that's the thing, if you have a teacher who will show you, who will guide you, it's very, I think it's a lot of fun when you have these paradoxes that you have to solve, and it's a fun way of learning the skills we need.
Yeah, I think, using those examples, is a great way to teach science and some of the problems that people are trying to solve, right? Whether it's a hairy ball problem or, how to hold a pizza, right?
Yeah.
On its own, a lot of these fields are kind of esoteric. People are going to be like, yeah, well, why do I need to know this?
Yes. And in many cases, you don't really need to know. But many things like this hairy ball theorem, for example, you can really easily go through your life without knowing this. But I really think it's just interesting. So, and we have this curiosity, especially children have this curiosity. But at some point, we learn to learn only these things that we will use at some point. And that's a bit sad, I think.
Yeah. I remember when I first learned about the hairy ball theorem. I think it was in a bar, and I was with a mathematics student, and he was drinking a beer, and he looked at me, and he said, every human being has at least one cowlick, or one or two cowlicks. And then afterwards he continued, and mathematics can prove it. And I'm like, what?
Yes.
So, it's also like a really fun way to explain how topology works and what it means. Yeah.
Yes, and you mentioned another really important thing, like maths should get out of classrooms as well, because maths is everywhere. So the same way we learn about ecology going to the forest, it's much better than, sitting in classroom and just learning by heart. The same with maths, going basically when something happens, we can, compute the probability of something or look at the shape. Math is everywhere. So I think the role of the teacher should be to point out where we should look for maths.
Yeah, exactly. So one of the other things that you talk about in your blog, or you write about, is women in mathematics, right? So
yes.
What are some of the obstacles, and how do you think we can solve some of these things?
So this puzzles me all the time, to be fair, because people ask me, what's your experience? And I feel maths is amazing field for women, for equality, because with maths there's there's an answer and it's quite objective, and you cannot have this fear like in many other fields that you get paid less because you're a woman, and it's very comparable. So I think my personal experience is very, very positive with doing mathematics as a woman. And yes, there are much fewer of us. So I'm used to being surrounded by men all the time. There were many conferences I went to that I was the only woman or one in a few. And I sometimes don't understand what's happening there, and it's still really difficult for me to understand. But I think that it starts early on. It starts in high school or even earlier, because girls hear that mathematics is for boys, engineering is for boys, science is for boys. You can do humanities or maybe biology and medicine. And I've heard this before. I've heard it as a child. And I think when you don't have female role models, when you don't know that women can do mathematics, it's really difficult to pick this subject.
So obviously you overcame that barrier, right? That, okay, girls can do mathematics. So was there any one moment that made you realize, hey, this is something for me. I can do this?
So I think I'm very privileged because my father is a mathematician. So maths has been in my house, all my life basically. But my mom is a lawyer, so it's not that it was an obvious choice for me. I was just really interested, but I was really struggling to pick my subject for university, actually, because I really love humanities. I really wanted to study linguistics. I was thinking of geography, of German studies. I had so many interests. So with mathematics, the choice was, basically, I thought maths is used everywhere. And even if it's not for me, I won't waste a year and, I will just learn thinking, learn logic. And I never regretted my decision because now I'm applying mathematics to so many different things that I can still, fulfill myself in so many areas, but using mathematics.
That's cool. So, as a science communicator, right, what do you think you need to do, or what can other science communicators do to help get young women interested in STEM or in mathematics in general?
I think the answer should be, first of all, the same for young women and young men, boys and girls, just to get interested, just to show how important it is. But especially for girls, showing that there are females out there and that we are normal, because many kids especially have this idea that mathematician is this old white man, old professor, sitting somewhere being really awkward, not talking to anyone, because that's what movies portray. so many movies about mathematicians are about mathematicians with some mental health problems, etc., etc. So I think just meeting, normal mathematicians who we are people as everyone else, and especially female mathematicians, will be helpful, to show that it's a job like every other job.
Have you ever heard of the Scully Effect?
No, I haven't.
Okay, so the Scully Effect comes from a character on the X-Files, Dana Scully. So she is an FBI agent. She's also a medical doctor. When she was an undergraduate, she did a physics degree. And her undergraduate thesis was on the twin paradox, Albert Einstein's twin paradox. And what they noticed was something called the Scully Effect. And what happened is that her character encouraged women to go into law enforcement and into STEM, or at least be interested in this. And for about 2 decades, this was just kind of like anecdotal evidence, right? You talk to some women who go to scientific conferences because they're scientists, and they cite Dana Scully as being that inspiration. And I think sometime earlier this year, the Gina Davis Institute for Gender Studies, I believe that's what it's called, they actually formally did a study on this effect, and they verified it. And I think what it shows is that a cultural icon, a positive cultural icon, can encourage minorities to choose a path they may not have otherwise chosen. And in this case, it's STEM, being a scientist. So I just thought it was interesting that you mentioned culture as being a part of this problem.
Yes, definitely. I mean, I personally heard so many times, it's not for you, pick something else, become a writer, become a doctor, it's mathematics, it's not for you. Just because I was a girl. So, and I was, because also I have this role model, yes, a father who's a male, but, he knows other mathematicians. So I was lucky, but not every girl is so lucky.
So what are conversations with your father like when it comes to mathematics? Do you talk about?
You mean now or when I was a child?
Both, now and when you were a child.
So now we sometimes talk, but to be fair, we are in such different fields that we don't really understand each other if we want to talk about some specifics. So yeah, of course, we sometimes mention what we are working on, but we don't really talk about it too much. But when I was a child and teenager, so he liked to just show me what his job is like. So I remember as a very, very small child, I used to disturb him a lot, when he was working, and just asking what he was doing, what it was. And he said, well, these are differential equations. And I remember getting so excited about these differential equations, having absolutely no idea what they were. They just looked cool on paper. And, then he was showing me some experiments because, yes, in maths we can do experiments. So I remember Mobius strip. He was showing me Mobius strip is the one-sided shape. And, we were just playing. And obviously, the older I was growing, the more advanced our conversations were. But he showed me it can be fun. It can be just playing around with the world and the numbers and what's around us.
That's cool. So what are some of your goals in science communication?
So my goal is what I mentioned before. I would like to reach people who don't like maths and who think that it's just useless and it's not necessary and it's not for them. Some people think I'm too stupid to do mathematics, which is it's not true. I've never met a person who is too stupid to do mathematics. It's just a matter of how we look at it and how we learn it and what we do with it. So that's my goal, to show at least one thing where this person can get interested. One field, one application that they can think, wow, that's cool, and math is actually useful in this particular area.
Okay. So do you have any final thoughts that you'd like to tell the audience?
Well, look, if you think that mathematics is useless and if you don't like it, check out my blog, check out other excellent blogs linked on my website. And if I didn't persuade you, please email me and then we'll try.
Okay, I'll be sure to put everything in the show notes, the link to your blog and your social media accounts.
Perfect.
So thank you for talking with me.
Thank you very much.
That was Paula Rowińska. If you'd like to learn how mathematics applies in your everyday life, you should check out her blog, Certain About Uncertainty. Links are provided in the show notes. The Science Bloggers is a community of science communicators. If you're a science blogger, YouTuber, or podcaster, feel free to check out our Facebook group. And if you're interested in checking out some interesting science content from our community, stop by our Facebook page. I am David Lashman, and I would like to thank you for joining in. As this is our first day, we have released 3 episodes of the Science Bloggers podcast. You can listen to our next guest, Chris Cloney, as we talk about the science behind dust explosions, the science of a particularly explosive scene in this summer's movie, The Equalizer 2, and ideas on running your science communication as a business.